Okay. Okay. So this is the revision history of the document. We started individual submission back in April 2010. We did 10 drafts. And then in August of 2012, we started as a working group document. It's gone on for quite a long time. I think we're ready to advance. But before I request that, just want to show you what the revisions were in the last few. So we had some comments, some substantial comments, or at least some commentary at the Prague IETF, and we reflected those. The comments that we got in Prague was after we made an update to say that we're going to have a registry that's going to define LCAF types for experimental use. The ones that are already in use, that are kind of standard ones, we would keep in the current document. And then the 12th revision was, since we kind of deprecated the Lisp map request signaling draft, there were bits in the multicast info LCAF that basically said how to do joins and leaves for multicast stuff. Since we didn't need that, I just removed the bits and in favor of the signal-free multicast stuff. I actually, that's a typo. It should say signal-free multicast in the spec, but anyways. So I think the author, I've talked to Dave and Job about this, and they said do whatever you think is right and whatever the working group thinks, but they believe this is ready to go to IESG. I want to know what the chairs believe, and most importantly, what the working group thinks.
Comments from the working group?
Yeah, I think, we've been around this document for quite some time. It seems ready to me. I see there is a provision to set up the IANA registry, so I think that is something that will happen after it's converted to RFC, right?
The IANA registry has nothing to do with the LCAF. Actually, is on the message types, which is not in the LCAF. So you will see later on that it's totally independent. But this is the IANA registry for the. Yeah. Okay. But the text has been updated, and we just need to move it forward and ask for IANA. But has been modified so to ask explicitly for the IANA registry to be set up.
And that will become automatic once it is converted to an RFC.
Yeah. It's after the ISG review, IANA has to say okay, and will create the registry at when the will be published. Yes, but everything will be put in place before, so it's
okay. Thanks.
Let's go. So, no other questions? So let's fill the room and what you think in general. So if you think that the document is ready to go for ISG review and move it forward, please hum now. Okay, some sound. Any objection to this sound that proves that there is some consensus in order to move it forward? Going one, going twice. No objections. So we will take it to the list for the normal procedures.
Crypto now, right? Okay, and this is the third update of the Lisp crypto draft that we'll present. This has had a shorter life, and we've actually been able to move quite quickly. I think the reason for that is because we got the SAG guys to get in early in the design and help us, so we didn't have to unravel anything that we did where we weren't experts in crypto stuff. So we started the draft, the individual submission in February of 14, became a working group document less than a year later, and we're on the third revision. I have implementations of 0, 1, and 2, have not done 3 yet, but we'll talk about that in a second. So the main changes, we had the SAG guys make a lot of interesting comments, and they're good with all the different ciphers that we chose in the cipher suites. They were worried about short keys, and 1024 bits are short keys. So they suggested for us to use long keys or elliptic curve. And so I'll show you the cipher suites that we decided on. The main change was that in the state of the art in security, authenticated encryption with additional data, or AEAD, is really very efficient because you can do authentication and encryption at the same time when you run the packet through a cipher. And so you get good performance benefits and you get authentication at the same time. Now, originally the charter of this specific spec was just to give data plane confidentiality, but if we can get AE for free, we'll take it, and everybody suggested that. So we changed a lot of the text to say, if you use AES, either CBC or GCM or ChaCha, to make sure it's AEAD and point to those sort of specs on how that's done. And by doing that, we were able to remove the ICV, the integrity check value, at the end of the packet. So the packet is shorter, but it turns out that the cipher will do it internally, so I'm not sure we're getting a packet size change, but at least the Lisp crypto doc doesn't have to deal with ICVs. What we were doing previously is we'd run through the packet cipher, and then we'd run through and do the hash, and that was a double pass through the packet. So this is good stuff, and they've blessed it, and they're doing it in TLS and other fora as well. So since we took the very last bullet there, since we took the Diffie-Hellman shared secret and we split it in half and made one thing to be used as the encryption key and the other half to be used integrity key, we no longer need to do that because we're just doing encryption. So we just call it the AEAD key. That was pretty much most of the changes. So these were the cipher suites we decided to add. If you look at the top two, CBC is still pretty popular and accepted by the government. So we kept CBC, AES CBC, the block cipher. And as you can see, the top one has 2048-bit keys, and then the second one uses elliptic curve. So we can use smaller keys, but it's harder for a man in the middle to guess to get involved in the Diffie-Hellman exchange and guess the secret. The next two are GCMs, because that GCM is regarded by the security experts as the way to go forward, and it has AEAD inside of it. So let's use 2048 and 3072, and then Cipher Suite 5 just says we'll use GCM as well with elliptic curve. And then last but not least, the really fast but hasn't been government, and no U.S. government has accepted this as a real cipher that's allowed to be used, is ChaCha 20 with authentication using Poly 1305, and they can do AEAD as well by the Poly 1305 being done internal to the ChaCha cipher. I'm finding with my implementation that I'm getting, so if you go through if a packet, this was with ICV computation as well, if you go through a packet of 128 bytes, it takes, on my quad-core MacBook, it takes about 11 milliseconds. Really, I'm sorry, 11 microseconds, and with ChaCha it takes 1. So it's basically an order of magnitude better, and I think I could just attribute it to it. It was all done in software, so we weren't using any hardware assist, and I just attribute it to we're not doing polynomial math, we're doing exclusive ORs and additions versus multiplications and exponentiation. So it's a good cipher in terms of speed for software implementations, but it has to be accepted. So I don't know if, so I talked to some crypto guys this week, and I said, if you had to throw any of these away, because 6 is kind of a lot of options, and you know, how are we going to recommend implementation? Should we tell them to do all of them? And when I talked to a crypto guy this week, he said the last one I would throw, he goes, I would keep the 3072 GCM, and if you're going to throw out any other ones, throw the ones that are not that. But he didn't say which ones. Okay, so. Okay, so my implementation status, I have my Lispers.NET is based on 0.2 implementation. There's not that many libraries yet that include AAD in it, so I wanted to keep the ICV support, but once they're available or I write my own, I could be compliant with 03. But what I did do since the last IETF is I added the Poly 1305 authentication to the Cypress Suite 6. And of course, the implementation support elliptic curve based on that curve 25519. And we can, so I was able to test and put in rekeying by doing RLOC probing. So if you want to rekey really fast, you RLOC probe faster. If you RLOC probe faster, you can find reachabilities to RLOCs faster as well. It's control plane based, not data plane based. So that's my question for the final slide.
Any comments from the room?
Fabio, mine again. What is the feedback you've got from the security gurus? You presented it at a given point to the security, to some security group, right?
Yeah, we didn't present the draft to them. We presented what we wanted to do. Like we first came out with saying, should we put keys in the mapping database? They said it's better to have ephemeral keys. That was kind of obvious. We wanted to use asymmetric keying, and they said those are really slow, use symmetric. And I said the requirement I threw to them was I only wanted a 2-packet exchange because, you know, while we're resolving the RLOC or trying to do Diffie-Hellman, we're dropping packets. And so they said, you know, what we're doing with Diffie-Hellman was fine. So those are all, everything you see in here is basically all their recommendations of what to do. A lot of people said, why not just use ESP? And they said, well, and others said, though, there's a lot of stuff in ESP that you don't need if you could do better. They were very encouraging, actually, not saying use my technology, but, you know, these are the things that we've done in the past that were good and these were bad. You know, let's look at doing things a little differently. And so they kind of gave us latitude to be a little creative. That was really great, you know, so.
I think in terms of advancement, that is the only aspect, right? I think to go forward, this will be vetted by security people. And if we feel that, you know, it has a chance, why not?
Yeah, I wanted to ask, Dino, you think all the technical issues are solved, right? You know, and there will be anyway a security review of the document. So,
well, yeah, I think it's in good shape, but, you know, I'm kind of an old-timer IETF guy. Really? And you don't that's obvious, right? You don't really go forward unless you have 2 or more implementations, and there's only 1 right now. So I'd like to see another implementation and get another implementer get a set of eyes on this to try to do it. So I mean, I've been soliciting with the Lisp mop guys or anybody else.
Yeah, okay, that's one point. One point was more that if we move forward, there will be a review from a security person that will review the document that you are confident about.
Oh, yeah, please send it through.
Okay.
Yeah. Yeah.
Okay, in this case, I would like to test the room and see if the room thinks that the document is ready to move it forward for ISG review. Please hum now. Everybody pretty shy today, but there was some sound. Okay, if there is any objection, please speak up now. Going once, going twice. We'll take it to the list. Thank you.
So one comment I wanted to make that, Fabio, you might be interested in is that we do have some requirements of the data plane. And since this working group is going to be chartered to support multiple data planes, we have to make sure that those data planes support some header bits that identify the key ID so we can rekey dynamically. We could do it in the regular Lisp header, but if we add GP or VXLAN, those are things that we'll have to consider. So I think when we entertain the different data planes, I think we should always think about security, right?
Sure.
Yeah.
We will discuss about this in Berlin.
In
with
Berlin.
The new charter.
Okay, we're not quite there yet. Okay, got it. Okay, so this is my last presentation. So what I thought I would do is, you know, the signal-free stuff has been pretty obvious and straightforward. So what I thought I would do is do a little demo. So I did screen, it's not going to be a live demo. even though it could be if you want to. But I did a little demo on a data center use case that uses signal-free multicast. So the problem statement is we can show how we could use the Lisp mapping database to store S, G multicast entry. And S and G here can be any EID. They could be a pair of IPv6 addresses, pair of IPv4 addresses, or MAC addresses. And for this demo, we're going to show them as MAC addresses. And what we're going to show is that we're extending a layer 2 service across 3 data centers. And the underlay is going to be an IPv6 only cloud with no multicast support. This is what it looks like. So we have data center A, B, and C. And we have these Lisp XTRs A, B, and C there. I made them multi-home, so they're going to have 2 addresses. You see that A has DF, AAA, but it also has DF, ::A as well. And you'll see that in some of the displays. Okay. And I have MAC A, MAC B, and MAC C all sending at the same time. And we have the map resolver and the map server, just a single system acting as the mapping database off the core and is reachable via IPv6. So the XTRs are configured to do L2 overlay service within a specific instance ID. So if you maybe had a subnet, an IP subnet that was in A prime, B prime, and C prime, they could run simultaneous here. And you'll find out from Victor's presentation how we could use a unified mapping database to support both L2 overlays and L3 overlays at the same time. The XTRs, when they come up, they'll register this S, G. So register to the mapping system is kind of similar to a join, but the state doesn't have to go everywhere. It just has to go in the mapping system. And what they're going to register as S and G is a 0/0 MAC address, which means any source that's sending to this broadcast address, FFF/48, will use this entry. And then we're going to show that MAC A sends an ARP request, and how does it get to B and C. So what happens, ITRA will look up SG, and then it'll find out that B and C have registered, and the map server does a semantic merge, not a doesn't do replacement semantics, it does merge semantics. So this S, G is stored in the map database with a replication list of B and C. And then when A looks up this SG, it sees that the ETRs are B and C, and it takes the multicast frame and unicast encapsulates it to B and C. So demo details are, I have the XTRs running in separate Docker containers on my MacBook. The XTRs are multi-home using those 2 addresses that I mentioned earlier. The MR and MS run in the container as well, so I have 4 containers running here. And the host Macs are talking all the time. So we're not playing any silent host games. Since they're talking, they're being discovered, so we know where to send them once we get into the layer 2 domain. And the single layer 2 broadcast domain is realized by an IPv6 unicast only underlay. This is the map server, and it's showing, so what I did here is my implementation actually allows the XTRs to register distinguished names as EIDs. So if you see up here, XTRA, the brackets means it's instance ID 0, so you can have different VPNs running at the same time. But XTRA is actually registering itself as a name, and you see the last register is DF::A. And it's also registering the MAC address that you see a few lines down, the 0/0A/48. And B and C are doing the same thing. Now, what's interesting is that S, G you see there in the middle, right? The last one who joined was C, because you see him there on the 3rd line as C being the last register. But if we take a deep dive and we click on that, oh, I had pointers here and I forgot it. So A is registering 2 EIDs. It's the MAC in red and the MAC in XTRA. And B is registering those 2 things. And C is registering those 2 things. So now let's go ahead and deep dive into the S, G entry. So if you look at the top, the entry is a 0/0 MAC address, an all broadcast /48. And if you look down here, you see that A is registered, and it basically said my RLE. RLE stands for replication list entry, is myself, AAA. Notice it's multi-home, so it has 2 addresses on that link, or it could have 2 links going into the cloud. So it's registering it, and that R, that capital R right here, is saying that I want you, map server, to merge this with anybody else that's registering. So now we see that B will register as well with his address, and then C will do the same thing. And then what you'll find on top is a merged entry. So that means everybody knows about everybody else. So if they get any broadcast messages, they know to encapsulate to the other two. It's pretty much that simple. There's no state in the middle of the network for multicast, and everything is in his central repository, which is central by view. The Lisp mapping system is centralized by view, but distributed for scale. Questions?
Robert Rashford. Quick question, Dino. So the XTRs are placed where in your case? On the TORs or at the compute nodes?
Well, they can go anywhere. Let me go back for you. Hold on, because you want to look at the drawing. So in this case right here, let's pick one, and then we can explain how it works. If these Macs are physical servers in the data center, the top of rack could be running Lisp, and so the encapsulation points are at the top of rack, which means IPv6 goes from midpoint all the way into the core. This could be in a data center edge router. Obviously, it could be co-located with the application in the same VM, or it could be in a hypervisor. It doesn't matter. It's wherever the packet flow goes, the data path of the packet goes. The A could be anywhere along the way. The closer you put it to the source, it means the underlay has to be extended. And the farther away you put it from the source, you do normal bridging or routing in the case of layer 3 to that point, and then the underlay is made smaller.
Okay, so let's assume it's on the TOR. So okay. It's a loaded question, because what I really after is, and I have valid use case, is to use this kind of Lisp overlay, but for multicast only, and leave unicast as today normal IP layer 3 forwarding. So would that experiment which you just shown the demo work if I only do it for multicast, not for unicast? Because then I don't learn all the Macs, by unicast.
Right, yeah, great idea, because I'm not endorsing layer 2 overlays here, because I'm really a layer 3 guy, and I really think it scales much better. But to answer your question, so I have to throw a question back at you. Will the guys who source the multicast, will they have different source addresses than sourcing the unicast? Because if we do a source EID lookup and say, this guy is Lisp, then we can do a mapping database lookup. Otherwise, we have to test the mapping database for the unicast case and then know that.
Today they have the same Macs and same IPs, yeah.
Yeah, but you could always put configured policy in the ITRs to say, I'm going to do Lisp for a destination, FF00 for v6 or 224/4 for.
By the way, so when the hosts and the IGMP join, do they actually get intercepted by the XTR and map and carried to the mapping plane?
Yeah, absolutely. In my implementation, the XTR, since it's a software-based implementation, they could be directly connected, so to speak, to the application, and they receive the IGMP reports, and that's what actually defines what the SCOMG is to register. Yeah, absolutely.
Any other question? Unless you have more slides.
I think I had the last slide. Questions?
Okay, thank you all. Next.
Fabio, you replacing. You want to use?
No, for the next one, because I have an animation, but for this one, I feel better.
Okay.
So I am presenting this on behalf of Albert Cabellos. He apologizes, but he wasn't feeling well this afternoon, and he went back to his room. This is about Open Overlay Router, and what it is. So, well, first of all, we call it OOR, that's a little more handy than Open Overlay Router. And basically, it's an open source implementation for specifically focus on overlay networks. We started the project, the community started this project many years ago. and it was called MOB. What we have done in the last year or so was refocus the project from mobility, from the mobility use case to overlay and programmable overlay, as we will see later. Not because this wouldn't work for mobility, but just because we thought that the use case of a programmable overlay is also, a very interesting area. So let's go to the next slide. So from that point of view, the implementation has been around quite some time, so it's fairly mature. The implementation include XTR either as an individual router or as a Lisp mobile node. And also there is a code for the MSMR function and for the encapsulate internal router. We are trying to, the community is trying to keep aligned the feature in between OOR and the Open Daylight Lisp flow mapping implementation. Open Daylight has a module that is called Lisp flow mapping, that is an implementation of a programmable Lisp mapping system. It uses Lisp as a southbound plugin to communicate with routers, and there is a northbound RESTconf API that can be used to program the mapping directly. One of the things that have been added is support for netconf YANG, and that's sort of the SDN angle, and netconf YANG is used for configuration and Lisp for operation. In terms of data plane, the community started with Lisp and then added support for VXLAN GPE. That is the multi-encapsulation extension of VXLAN that supports layer 2 and layer 3. And it basically, if you want to, the convergence of Lisp and VXLAN to support multi-payload. Next one. The platforms, there is an implementation. The code base is the same, and then from same code base, the community pulls the Linux, the Android, and the OpenMP distribution. Next. So the idea is to provide a tool for overlays, very specific to implementation of overlays. As the name says, right? It's an overlay router. Next. And you can see a little bit of the architecture of the whole combination of a programmable mapping system and a controller and the OOR data plane. So the idea, as I mentioned before, is that we have a controller module that basically is the network information base, and so contains the state of the network, the state of the overlay, and that is programmable through northbound API. So one can build application on top of the controller, and then the OOR data plane that basically pull the state on demand. Next. And this basically is reinforcing that concept, right, and showing that you can have a whole open stack that includes Open Daylight, OpenStack for provisioning of the infrastructure, Open Daylight as a controller, and OOR. The protocol, as we mentioned, we have Lisp for operation and netconf YANG for configuration and management. Next. So OOR is not a traditional router, is focused on providing an encapsulation associated with a physical interface, and also support some extension of Lisp. Some of the features that have been implemented in WR are in some of the drafts that have been presented to this working group. Forwarding can be done not only on destination mapping, can be done not only on destination ID, but also we support generic mapping. At this point, support for 5-tuple mapping, so you can map a 5-tuple. I'm not sure it's exactly the entire 5-tuple, but at least the source ID and destination ID, but probably the whole 5-tuple. And also different mappings like NSH, SPI, and index to use the protocol as support for NSH. And this is probably a trend that who made the previous question about multicast. About multicast, we are kind of seeing, we see a lot of people from different community that are thinking about using the Lisp map and encap database as a support for different protocol. And so NSH is one example. There is a draft out that is basically showing how the Lisp mapping can be used to provision on demand the location of the SFFs for SFC. Another example that I've heard is somebody from the beer working group that has done some prototyping to use the Lisp mapping system to provision on demand the mapping for the beer bitmap. Next. So here is a few aspects of things that are in progress. One of the things that the community is doing is start thinking in terms of what is an overlay router, and especially an overlay router that supports multiple mappings. So the idea is that you could associate a list of mapping to a particular interface, and then on receiving a packet, the list will be applied to the packet itself. So it happens to be an NSH packet with an NSH header. The first lookup will be the SPI index lookup. If it is a VXLAN GP encapsulated packet, it will be a 5-tuple lookup, and so on and so forth. Okay. And here is the architectural concept, right? The idea is we keep all the state up in the mapping system, that is the black block there. And the mapping system is programmable from the SDN controller itself. And the SDN controller is basically rendering the intent level policy that is programmed via the northbound API to the controller in terms of mapping. And then, as we mentioned, right, we use netconf for provisioning, Lisp for operation. An important aspect is that when we start looking at different use cases, it becomes important not only to be able to pull state from the mapping, but also being able to refresh the mapping on the XTRs themselves. And the reason is that the moment you make the mapping system programmable, the state can change by northbound API and not because of registration of the tunnel router. So that's the reason why there was, a simple proposal to extend the Lisp protocol to provide a publish-subscribe mechanism. For example, in NSH, if you define a chain and you support the NSH protocol, to map SPI index on the next SFF locator, a change in the chain definition will need some push mechanism or publish subscribe mechanism where the nodes that are part of the chain are subscribed to the change in state of the chain itself. Okay, next. Some idea and things that we are kind of considering. More of this, the community includes a lot of researchers, so many people are kind of using the platform as as a tool to test a new idea. And one idea that has been thrown around is think in terms of having a flexible LCAF language. Try to figure out what is a good pub/sub mechanism and aspect of this kind. So the distribution is done very well. The community is very good. And for example, if you want to try the mobile implementation for Android, it's in the Google Store. So, and it's a user space app. So just download and you can start playing. The community is also supporting the administration of EID, and there are a few OpenMSMR part of the Lisp beta network that are available. And if you want to start playing with Lisp, is a great chance. Next, I think is the last. Yeah, okay, done.
Okay, one quick question, if I may. This is Joel Halpern for the minutes taking. I can't quite tell from the slides whether this is a complement to or an alternative to the FIDO ONE.
Oh, good question. Yeah, thank you. So another aspect, and actually we forgot to put it on the slide here. There is a open source project that was started a few weeks ago that is called FIDO, FDIO. Fast. I don't remember what FIDO stands for, but Fast Data Plane IO or something like that. But basically is a set of a set of tools that work on top of the PDK to provide very high speeds and very efficient data plane operation. And some member of the community, of the WR community, have been working also on the FDIO community. So one of the things that we are doing is integrate FIDO with WR. So they definitely work together. Actually, a couple of guys from the WR community are in San Jose this week, and there is a training going on for the FDIO, for the FIDO open source community.
Thank you.
Thank you.
I had a comment as well. I managed to go back. Here, when you say forward packets based on different fields, so is this based on the draft Albert once published about how to do find mappings, look on different fields? Is this,
yeah. The idea is, and next presentation will also mention some of the rationale behind those evolution. One idea is, and I think is one possible evolution that the Lisp protocol could take is, look at different applications. So not forwarding, not or pure forwarding, right? Like the multicast that we mentioned, or NSH, or whatever. The other is, if the tunnel router is capable to do a more fine-grained lookup, then we can enforce, we can enforce basically more sophisticated policies. And I think my next presentation will actually provide a couple of examples in the context of SD1.
Okay, any questions?
no, let's move to the next.
It's not seeing you. There.
There we go.
So this is about draft minor GPE VPN. And those listed there are the other authors of the draft. The draft was published a couple of weeks ago, and if you have a chance, please take a look at the draft if you haven't done it already. So basically what we have been trying to do with this draft is think in terms of a particular use case, a software-defined one, right? So a programmable VPN use case, and how Lisp can be used as a programmable control plane in combination with Big-Stan GPE for the data plane. And also, we wanted to start thinking how you would combine that encapsulation with encryption and support for other, tags or function in the data plane itself, like NSH. And one of the concepts that comes out of the presentation is that we think that the value of having an overlay can be multiplied by making it a programmable overlay. And in particular, because that gives us a unique characteristic, right? With Lisp, we pretty much have moved the state from the network to the mapping system. And now, if we have a way to modify dynamically that state, it becomes very easy to render different policies, not only forwarding, but we will see other kind of policies in the network itself. And we can dynamically manipulate the mapping and be much more sophisticated and basically start looking at different policies that are not only forwarding. So the overall architecture we have in mind is the following one. We have an underlay, right, that is a router, and each one of those router is an XDR. And then basically we have a few components that are part of the of this architecture. One, the gray module there, is the auto configuration, orchestration, and policy resolution module. Basically, it's the orchestration module that is responsible for providing the orchestration of the system. And then we have a mapping server that is a Lisp mapping server, and a key management server that handles the key for encryption. The function of the key management server and mapping server are, logically separated, just because typically in an implementation, keys are kept, in a safer place than everything else. But, they can be part of the same actual piece of software. And that mapping is programmable via a northbound API that is typically a very simple RESTconf API. And what we try to do with this architecture is to separate the stateless part of the policy with the stateful part of how policies are rendering. Because basically what we want to do with a programmable VPN is start from an intent-based policy that is basically expressing at a very high level what our VPN wants to do. And then that determines the infrastructure of the SD-WAN solution itself. And as part of orchestration and provisioning, the orchestration infrastructure can start configuring the various standard routers that are part of the SD-WAN solution, but also the infrastructure that will support the programmable SD-WAN, like the mapping system and the key management server. And this can be done, automatically, and you can use typical, application, typical solution like OpenStack or this sort of thing. But at the end, you basically have a network that is ready to support an overlay with a mapping service that is available to the element of the overlay. Typically, the configuration of the router is very simple because it's the typical Lisp configuration of an XDR that is pretty much just the IP address of the mapping server and a couple of other parameters. It's actually simpler than the provisioning of a Lisp typical XDR because we are not provisioning the mapping into the XDR. But the mapping are basically rendered through policy resolution from the intent-based policy to the stateful mapping that is part of the mapping services. So in this way, now we have sort of one first level of abstraction that is express what we want to do with our overlay. And then this is translated by the orchestrator in state. That is how we are going to do that in the network. And then, you know, we use the typical Lisp pool approach, right? That is when the XDR receives a packet, it will look up for the state, and the required tunnels will be provisioned on demand. In this case, we are, for example, providing a traffic engineering policies, and we are send the packet first to router C and then to router A, that was the destination. And this is the first example of what you can do with mapping manipulation, right? Typically, we use the mapping system to define, to look up an EID and the destination. But now that we have all the state and we can program that state from the northbound interface, we can sort of change on demand, change dynamically that kind of policy. So if we want to implement a traffic engineering policy in the overlay, we can do that by changing the mapping via northbound API. And that will translate the intent-based policy that was, okay, I want all the traffic going from E to A via C in state actually available for the network. And in this way, we pretty much build the whole overlay, and we have this stateful repository of mapping that is available. So I have a few slides on the data plane, and some consideration on the encapsulation, right? So what you see here is the VXLAN GPE encapsulated frame that is, it's very similar to the Lisp frame, very similar to the VXLAN header. And the most significant difference is the fact that we have an X protocol. So the payload can be any of the payload that can be carried. So, for example, today we have defined a protocol type for Ethernet, for IPv4, IPv6, ESP, and SH. So in this way, we can encapsulate any kind of payload. So in the next slide, we look at how we would combine that with ESP, for example, to provide confidentiality. And this is the kind of idea. We use, one of the requirements is not only providing confidentiality to the payload, to the actual payload of the encapsulated packet, but also to provide integrity protection to the GPE header, because the instance ID, the VNI packet that is there, could be subject to tampering. So typically, what one could do is to use an AEAD, that is an authenticated mode of operation of some ciphers that provides also authentication to what is called the additional authentication data. That is an extra part of the actual payload that is encrypted that not necessarily has to be together with the ESP payload. So in this way, you see that we pretty much cover the integrity of the VXLAN of the GPE header, and then of the entire ESP payload, and then we provide confidentiality to the actual payload of the ESP packet. Oops. Here is an example of combining ESP, GCM, and NSH. And GCM is one of the multi-operations that can work as an AAD. So it's just one. There are others, but it's one. That
I saw this diagram in the document and I got a little bit confused because you've got the NSH header and at the very bottom of it, you've got something that says the next protocol after that
right.
is NSH, but
Yeah.
that's not. The next protocol after that is actually the next protocol as indicated in the NSH base header, which is IP Ethernet.
Right. No, let me see. No, maybe you're right. No, because ESP is kind of weird, right? So the field that tells what is the payload of the ESP encapsulated packet is at the very end, because you need to decrypt the whole packet anyway. So this is saying that the next protocol after VXLAN GPE is ESP.
Okay, so that field is the ESP next header.
Right, exactly.
Okay, because everything's called next protocol. So we have the GPE next header field,
Yeah.
the NSH next header field, and the ESP next header
Right.
field. Gotcha.
You're right.
Thank you.
I should qualify the NP with VXLAN GPE and yeah.
Now I see how it works. Thank you.
ESP is a little weird from that point of view.
Yeah.
So what we can do here is protect also the confidentiality and the integrity of the NSH header.
Is it okay to ask questions?
Sure.
Yeah. Okay. Since we're talking about headers, the next protocol equals ESP is really not true, because ESP is an IP packet with protocol number
Right.
50.
Right.
So, I mean, it should be called something else if you're just using the SPI and sequence number field.
Yeah, that's a good point. So we are kind of hacking a little bit with the protocol definition, because ESP as defined today is defined as a payload of IP only. But in here you will have to do some of the binding, right, with the but yeah.
Well, that's actually, it's a more important point. Thank you for raising it, Dino, because if this is not straight ESP, then we have, if we want to use it, if we want to define it to behave this way, we're going to have to liaise closely with the security community here at the IETF
Right.
for the definition.
Right, exactly. And yeah, it's basically a different application. What I think is valuable of using ESP is that there are many, implementation of ESP around, and both software and hardware. So it might be a little simpler, to reuse those.
So my comment on that, this is Dino, is that the advantage of using ESP, it's government accepted and we know it's useful. The disadvantage using it with Lisp is we have yet another 20 bytes of header.
Yeah,
So
exactly.
choose which way you want to.
Exactly. Everything has a price tag, right? So some consideration of the mapping types, and this is a sort of one first evolution that I think we could see for the Lisp protocol, right? And we've been working as a Lisp working group on mapping of EAD into RLOC, but now I think this sort of use case shows well how you can think in terms of different mappings or different form of mappings, right? And the first direction is trying to provide more granularity to the mapping itself. Because if I want to manipulate the mapping to apply a certain policy, if I can map only on destination EAD, then I'm limited on what I can do. If I could map on the entire 5-tuple, then I have the capability to impose the policy that I want to impose per flow, for example, or maybe I can look at the protocol type. So there is more granularity. And this seems a thing that it's interesting. Sure, there are implications in terms of implementation, because mapping a flow is different than mapping an EAD. But if we look at the evolution of software and even hardware, I think this becomes more doable now. And I think this is your question, Luigi. Draft Rodriguez-Natali's multi-tuple EAD is the one that is mentioned in the multi-tuple mapping. And the other aspect is extending, but let me finish this, Dean, and then extending the mapping system function to a generic mapping, right? Where we can map any value, on its location. And this requires a little bit of redesign in terms of the mapping system, because the mapping system now becomes probably a more generic database where you can map very different things rather than being just a mapping system that maps IP addresses. And some of the ideas behind this, in the example for NSH, are in those two drafts, draft Ermagan Lisp NSH and Rodriguez Natal Lisp MSSMR. Please.
So regarding the 5 tuple, it's going to present a scaling problem, and yes, you get more granularity, and it can be useful for service chaining. But a lot of merchant silicon as well as proprietary silicon have wide SRAMs, but they're wide because they want to support IPv6 or IPv6 multicast. So 128 bits of S and G, so they go only about 256 bit wide. Most of the 5 tuples are in separate access list-based memories, which are usually small and slower. So you have to be careful that this is a Frankenstein, right?
That's true. That is certainly there are different requirements. I think if you limit only to source EID and destination EID, you already can have, you can do very nice things, right? So that is kind of the idea, the general idea, but then, when you look at an implementation, it may make very much sense to limit that capability.
Will we have to store flat NSH SPIs in the map cache?
Yes. Yes, because when you look up by NSH.
With no structure, they're like host routes. Sigh. No structure to them at all?
They are flat, right? They are tags.
There is no structure to NSH service path IDs. However, the total number expected in any system for them is expected to be fairly modest compared with most other situations. So
10 to the third?
What?
10 to the third?
10 to the third possible, 10 to the fourth extraordinarily unlikely.
It's a lot of service, right?
That's a lot of
A
service
lot of
paths.
services. Yeah. All right. And then if you have these two kind of extensions, right? So if you have a finer grain capability to map to do map requests, and if you have a more generic mapping system, then you can think in terms of so what are the policies that that we can render by simply manipulating the mapping, simply changing the mapping via northbound API. And so these are some examples. I don't think are all, but I typically discover a few more when I talk with people. Lisp does the first one, right? It's basically taking care of forwarding policy and inbound load balancing. And this is what Lisp has been done since day 0. But then with the addition of RTR, we have started the idea of introducing overlay re-encapsulation in the mapping, and that allows you to create virtual topologies or hierarchical VPN in this particular use case. So it gives more possibilities of implement that sort of policy. Another aspect, for another policy that you could implement by using a dynamic mapping is a group-based access policy. So if you want to create groups based on the identity of the endpoint, and then you want to filter on the groups rather than on the identity itself, you can do that filtering on the mapping system itself. So if my endpoint belongs to a determinate group and wants to talk with a endpoint that is part of a group that is not allowed to talk with me, then the mapping system will just return a negative map reply, and the packet will not make to destination. So again, that's an example on how you can change the mapping and how that allows you to implement a different policy. Support for service channel, and you had mentioned it a few times, right? This is another example of a policy that you want to, that you may want to implement. And this is relatively easy because really you program the high-level policy, you convert it into state, and then you keep updating that state depending on the policy that you want to. A note on key management services, and this is basically what you were saying, Dino. So I think, and that I think came looking at the work that you have done with Lisp crypto, right? So Lisp has done an incredible job of simplifying the provisioning of tunnel dynamically, and that is now possible in a very efficient way. So now when we combine it with encryption, we sort of start to go backward, because if I have to set up a security association before I can start sending the first packet, then I'm losing some of the advantages of Lisp. And this is what I think Lisp Crypto is trying to do, right? It is to say, no, I want to send that packet out as soon as possible. So I'm trying to do as much as I can to provide encryption material so that the packet can be encrypted as soon as possible. And you can have different levels, right? Another approach could be to use GDOI for group key distribution. That simplifies a little bit the problem compared to full IPsec, because you can push keys to the XDRs, and the XDRs that belong to the same group can start encrypting after they have converted the key in a transmission key. So still requires a little bit of cryptography, but it's better than IKE, right? Where you need to do a full IKE exchange before you can start doing you can start sending the first packet. And there are sort of security implications that you pay in terms of security association setup time. For example, if you use group keys, then all the XDRs are sharing the same group key, and compromising one XDR leads to attacks on any of the XDRs that are encrypting with that key.
This is Dino. So first off, all the security guys say when you share keys, they're evil, because they can get compromised quite easily.
Right.
And in the case where you say all XDRs are part of a group, because you've been using some language provisioning tunnels. Lisp really doesn't provision tunnels. It just has a route, just like a fib route. No different than you need to encapsulate to an Ethernet next hop, you encapsulate. So it's not provisioning where there's hard state that's set up. And because of that, you don't know who all your XTRs are going to be, because you don't know who you're going to talk to yet. So you can't do these pre-shared keys sort of thing. I don't know how that can actually work in the real world.
And that's part of kind of going backward, right? Because now, for example, if we want to we want the super safe solution, right, of using IPv2, because we use keys that are unique for each for each node, and then for each link between the two nodes, we use a different key that is negotiated using an IKE security association. But then the point was, I was able to reduce the state needed in the node for encapsulating the traffic, but now for encryption, I need to be ready to encrypt to any potential destination. So I lose the advantage that I really get with an override. So I think there is work that needs to be done there, and clearly you are going in one direction that I think is one possible solution. Just trying to list there, what are the existing solution at least, and that's it. So go ahead.
Sorry, I have a question. Can you go back to the SDN slide where you have the, that one right there. So you're using ELP as the way to transit through, right? Or
not necessarily. You could. Okay. One of the driving principle here is trying to use the XDR capabilities as they are defined today in what is most implemented. So you could really just send a regular map reply without an ELP, because you can look, for example, to who is asking, and you return a different destination depending on who is asking.
So my question is down there where router C is, there might be a pair of routers with enough network redundancy, but they're paired in the same region.
Right.
And what the TE draft says with ELP, or even returning it separately, as you say, we'll RLOC probe, and what's the router? I can't read it. The one
this is E, and that is
E?
A. E and A.
E. So E will RLOC probe the pair C and C prime and switch back and forth depending on reachability or RTT changes and stuff like that.
Right.
If E notes that it has to make a change, I hope the controller is not involved in that, because it's kind of a local network matter. Does the controller get involved on what E chooses as an RLOC?
Well, that's part of the proposition, right? So if you keep the state here and there is a change of the state that comes from the northbound API, then you will have to inform.
There's no change of state whatsoever. There's a change of state in the underlay that the
Okay.
provisioning guy doesn't know.
So yeah. So it doesn't mean that the registration from the XTRs goes away, right? Because you can keep using that as a way to understand the state of your overlay and
So
underlay.
E has autonomy. It doesn't always have to listen to the controller.
Exactly. Or there is some degree, between the two.
It's a negotiation. Okay.
Depending on what you want to do. Any other question? Okay. So one question I had for the chairs is, I don't know exactly what will work with, how it will work with the new charter. So we submitted this as an informational FC, just, I didn't know what to pick. So whatever we will need to do, we will do it. At this point, I don't think it's important.
Well, looking at it, it looked more like a description of how to use a set of tools rather than a description of new protocol.
Right.
As such, it would likely end up informational, but we'd have to work it through.
Yeah. And one goal that we had was kind of, since we have introduced some of the drafts proposing, extension to the Lisp protocol, this is kind of giving the rationale, right? So why those drafts exist.
So this would be an informational complement to those.
Cool. Another question?
Hello, my name is Dennis. May I ask a question? In this diagram, it would be natural to have the tunnel straight from, let me say, from left to right and the other way around. So is that where, on the mapping server, where you define how it would be best for the routers to connect to each other? Is that what the diagram is trying to say?
That is a function of the policy that you want to implement, right? So if you want to implement straight forwarding from E to A, that's what the mapping system will do. Will return right away the A address. But this example is showing that if you want to do some overlay traffic engineering, you may send the packet first to a node and then to another. For whatever reason you may want to have to do that, right? Maybe, I don't know, this path, even not being direct, is faster than the other path, or some characteristic that reflects the high-level policy that you have there. For example, if you want to implement a hub and spoke topology in this VPN, and you have to have all the traffic going through the hub, that is what the mapping system will do. When one of the spokes want to talk with another spoke, it will first send the traffic to the hub and then back to the other spoke. And when the hub wants to talk with the spokes or vice versa, they will send it directly. And the interesting part is that you can do that dynamically now. If you say that these two can talk directly because they are in the same region, but when they talk with the other region on the other side, they have to go through the hub, you can do that as well in the mapping system.
I see. Thank you.
Thank you.
Thank you, Fabio.
Okay.
Next, Victor.
You can pull the mic down a little bit. Or just take it off, whichever works better for you.
Let's see if this works. Okay.
Yep.
Okay, thanks. So we put together a draft documenting some aspects of EAD mobility and how this actually tends to lead to the combination of L2 and L3 services. There's the co-authors and participants on this. If we go to the next slide. So the scope of the draft covers basically implications on L3 overlays, L2 overlays, all in the context of EAD mobility. There's some interesting cases in the case of L3 overlays on how we actually can use those to cover or address intra-subnet traffic that may be dispersed across sites, and I'll talk about that in a little bit. We also go into details of what implications are of introducing L2 overlays as services within Lisp. Things like can we assist ARP resolution with the Lisp protocol, and what happens in terms of multi-destination traffic. There are still some other things that would need to be worked on beyond -00, but this is our start. We'll go to the next slide, please, Luigi. So an L3 overlay with no dispersion of a subnet, basically where subnets are indeed affiliated to a site very distinctly. That's basically what we've worked on so far in the IP space, fully defined in 6830. The subnet dispersion case is what we've actually documented here. And what I mean by subnet dispersion is the case in which you have a certain degree of freedom in assigning IP addresses, or where the IP addresses that are assigned may land. A lot of people refer to that as mobility. It's very common in data centers with where you have virtualization, and we expect it to be more and more common. So in this case, the IP addresses may land in many places, but there isn't necessarily a layer 2 connection between those different places. By using host registrations, we can actually provide connectivity for those hosts, both extra subnet and intra subnet. In the case of intra subnet, basically what takes place, and some of the methods that we've defined in the draft, include basically the registration of the hosts, of the EIDs as at the host level, and basically providing mechanisms for the ITRs to proxy reply on behalf of any remote hosts so that they attract traffic to themselves if the traffic is destined to an intra-subnet destination, but it's not on the same site. So we basically insert the ITR on the path of what would normally be within a layer 2 segment, and that allows us to basically make a routing decision, and we were going to make that routing decision based on host information that is registered in the mapping system. The implication of this is that we're going to follow routing rules to the T, and there's going to be some decrements of TTLs that will naturally happen there. This will work for IP traffic only within a subnet or across subnets. Go to the next slide. Then we look at the case also where we create layer 2 overlays. This is also something that is a new proposition in this draft. Very simple. We're going to basically have MAC addresses be registered as EADs in the mapping system. All pretty much the same encoding as an IP address today, with the AFI being an AFI of 6. And we're going to do it within the scope of an instance ID. That instance ID, in general, you can expect it to be dedicated to an L2 service, because there is a corresponding map cache that should actually be instantiated in the ITRs. Is it mandatory that it's a separate ID from that of the layer 3? Probably not. But you get the idea. Most platforms are going to have a bridging table and a routing table, and those are going to be separate. But you can discriminate further in an implementation by having basically the tuple of MAC and IID, and basically select the tables accordingly. In any case, this would handle both non-IP as well as IP traffic that is intra-subnet. Okay, but in general, it's the IP intra-subnet traffic is a special case of non-IP traffic at that point. We go to the next slide, please. So some of the things that are important when we're providing an L2 service, multi-destination traffic, right? One of the comments in the room earlier when we were presenting signal-free is that we could probably use the solution exclusively for multi-destination traffic. In the case of layer 2, it's probably the most prevalent traffic, probably why it continues to be used in many scenarios. So the ETRs in the model that we proposed, the ETRs would all register to a common multicast group, and they do that predicated on the fact that they may be provisioned to participate in the same layer 2 overlay. Okay, they have the same layer 2 IID. So what that means in terms of signal-free multicast is that we're going to basically register our interest in being part of a replication list for a MAC level EID. Right, and Dino gave some good examples of a MAC level EID. He had basically an EID that was source anything, destination broadcast expressed basically in MAC address terms. So when traffic comes into that ITR, you will basically get a hit based on source and destination, and you will then proceed to replicate according to the mapping that you download from the replication list that you download from the mapping system. For linked local multicast, you would basically subscribe your interest to a more specific type of mapping, basically one with a mask of 8 bits. So we're going to use this as a flood service for both linked local multicast and broadcast. Unicast would be, unknown unicast would be treated as broadcast as well. And the consideration here is that unknown unicast is in most cases a temporary state. So eventually the unknown hosts become known. So we have to basically do a little bit of follow a process that's a little more detailed, right? So what we'll do is we don't know for initial packets come through. We at this point, if we don't have a cache, we need to check if there's an entry in the mapping system. We will get, if this is something that hasn't been discovered, we're going to get a negative map reply. We documented the negative map reply to use no action. There may be an item there of requiring more semantics on the negative map reply or not. We think no action covers the case, but up for further discussion. In any case, when we get this, we're gonna cache an entry that basically tells us to use the broadcast facility. So the broadcast facility is basically the FFFF. So it's not a direct match on the destination MAC. At that point, we're basically mapping unknown destination MACs to that broadcast facility that we subscribe to. At some point, the unknown unicast is actually made known. And what we will do is have the ETRs that are receiving this flood where it's been known actually trigger an SMR and have that SMR actually enable the ITR to refresh its cache, right? So from that point onwards, you have a specific entry and you no longer use the entry that was cached from the negative map reply. Okay, so that's regarding multi-destination handling. We go to the next slide. Oh.
Could you go back one slide? This is Dino. So regarding the unknown, saying you can use the FF, you could actually put, an implementation could put a 0/0, 0/0, and it would just automatically match it. And all you'd have to do is inherit this 0F RLE into that entry, and then the route lookup would always match on like a default route, which could be the flood list. So an implementation would not have to use the following logic. If I look this unicast MAC up and it's not there, now I go look the broadcast up and get those RLEs. The 0/0 could just be one step and it'll be faster.
Good. So we need to think how we generalize that in the text so that right now it doesn't have that flexibility, but we can, we can write it that way. So the L2 overlays, they can also handle IP traffic that is intra-subnet traffic. And the implication there is that there's going to be basically an ARP resolution that's going to give us the MAC address, and then from that point onwards, we just treat it as layer 2 traffic. In the draft, we specify a mechanism for intra-subnet traffic that is based on L3. We also have one that's based on L2. When you read the title, this is unified. It doesn't mean that we're proposing that you handle hosts for intra-subnet traffic in both manners, but they're exclusive. They're mutually exclusive. And basically, as far as ARP goes, we're proposing a configurable option where the first option is to simply just flood ARP requests in the broadcast facility that we've subscribed to, and basically let ARP do its thing at layer 2. Or we could, it's been of interest to many customers and users to actually suppress these floods and minimize the amount of ARP traffic that is actually being sent across the network. So from that perspective, we propose a mechanism by which the Lisp mapping system can help in resolving ARP requests. So the next slide, we look into that mechanism. So what we're suggesting basically is that the registering ETRs, not only do they register the fact that they have hosts connected to them, but we're going to also register the host, the IP to MAC address binding. And we're going to register that in the IID that's being used for the L2 overlay service, because this is relevant to an L2 overlay. One of the things that we were careful to do in the draft was to allow implementations to be compliant, whether they were only layer 2 or layer 3 only, or both L2 combined with L3. So in the case of ARP, basically we're going to register this in the IID, that is the IID for the L2 overlay. We're going to register it encoded as suggested here on the slide, and basically this is an LCAF list, and the EID is the IP address, and the locator has a series of parameters, one of them being the MAC address. So that's our binding of IP to MAC, so that we can actually look up in that instance in the mapping system. We can look up an IP address in that L2 instance, and we will get as a return the MAC address, which basically gives us the binding. So when an ITR is operating in this mode, it operates as an ARP agent, not so much as an ARP proxy, because it's going to regenerate an ARP reply that is basically equivalent to what the real host would have actually replied with. So the first thing that we do in the ITR is when we get the request, we're going to cache that so that we know whom to get back to. And we're going to issue a map request with the EID being the IP address and the IID being the L2 overlay. We get a map reply. We're going to cache that. We're going to cache that for future replies. So there's an implication that in the ITR there is an ARP cache, either the ARP cache that's already in there or an ARP cache that is specifically implemented for these purposes. At that point, we're going to be in a position to actually assemble an ARP reply with the information that we had cached for the requester, as well as using the source parameters that the responder would have actually used if they had responded themselves. In the case where there isn't any such registration with the map server, basically when a host is still undiscovered, we're going to basically receive a negative map reply, and that is our trigger to actually put in place a negative map reply entry and fall back to the flood mechanism. So we actually fall back to flooding the ARPs. Okay. Next slide. Okay, next step, this slide I should have updated, but there's a few next steps. Inviting the workgroup to participate. We just posted the draft. Go ahead.
But now I just have a question. How do you detect that your cache is actually stale? I'd like to understand how you do the negative, situation, because there's no explanation here. Have you guys given that a thought about how and how much time you're going to take to detect it, whether your cache is now stale, or are you going to wait for the next packet to go in and realize that it's stale?
So we'll keep, right now, what the plan is to keep the negative entry in place until it either times out or we get basically a triggered SMR. And the SMR would be triggered by data plane events.
Yeah, because the reason why I'm asking this is because when we talk about mobility, then this is going to be an issue. We will need to have a way to detect this very fast, because these are going to get stale really fast, right?
Yeah. So I think as of right now, mobility is relatively lenient and we can actually get away with some things, but you're absolutely right. Moving forward, we're going to have to tap into northbound APIs, as I was saying, and actually get more timely information from engines that are actually bringing up and down containers and all sorts of other things.
So this is Dino. So when somebody moves and actually just doesn't leave the network but reattaches, their new RLOC goes automatically to the mapping system. The mapping system knows to send map notifies to the old RLOCs. So it's all event triggered. Okay, so that means that the old RLOCs have this moved away state. So if somebody encapsulates them because there's still packets in the network going to the old RLOC, they could do data-driven fixing of the guys who are encapsulated.
Right, and that's one part of the draft actually, is that mechanism. Yeah.
I have a question because there's a distinct, there's two situations, right? You might be moving, but you might also be gone. So how do you detect that? That might be something that we might want to look at. Maybe you have already.
No, yeah, the gone case is really not handled well, because then you have to wait for timeouts. So what happens is packets are going to the old location, getting dropped on the floor. It's unfortunate because the ITR is using resources encapsulating to a black hole. If we can detect that gone sooner, unfortunately, when hosts move, when they arrive, they don't announce that they arrived. They just start sending data packets. And when they leave, they don't say goodbye, right? And so, I mean, we've always wanted better host to router protocols. And we almost did this with IGMP, where IGMP subscribed and said, I want to hear something. But of course, multicast sources never said, I want to start sending. This signaling is something that we should have put in the IETF like a really long time ago, but we never did.
Most probably because I come from the IGP world, I want to see, hey, you're alive.
Awesome. So the invitation is for the group to review the draft, and all of these are extremely important points that we would like to cover there. The question also for the group in general is, would this be a good document to use as the canonical reference for mobility, or how do we want to handle this moving forward? It's too early to ask about workgroup adoption.
I think it's too early to sort that out, but you guys need to talk to the authors of the existing mobility documents and see how you suggest we align them. Because they certainly should be aligned. Whether they get combined or not is probably a detail I'll leave to you guys.
Okay.
This is Dino, so I have a feeling they are the authors of that document.
Well, then they can
Yeah.
decide how to handle the text in a consistent fashion.
I think an important point here is we're finding that what is actually moving. We're finding that containers move, VMs move, smartphones move, cars move, sensors move. And from our point of view, these things are all signed relatively static EIDs. And if we could just solve an EID moves, to us, it's just an address. And by solving it well, we will solve it for all those high-level use cases. And hence why the document is called EID mobility and not VM mobility or Lisp mobile node. So I do have a question that we do have a document that's been around for a long time called Lisp mobile node. And the difference between that and the examples I used was the RLOC and the EID was co-located in the same physical device, where in these scenarios, the EID is moving and the RLOC is in a stationary top of rack or base station or something like that. So the question I have is it good to keep those two separately because of where the RLOCs and EIDs are, or should they be combined?
I just have a comment. Yeah, you make a very strong distinction because between the node and the EID is not the same thing. And I think that the EID pattern and behavior is going to be very different from the node. So the solution that you're going to have for the node is going to be very different. And so we can take this offline and discuss more, but definitely
That's a very good
I
point.
think it's another problem.
Yeah, I tend to agree with the view, RLOC mobility, EID mobility, but we should discuss more.
You're saying you should say separate.
Yeah, separate.
Okay. Any more question?
Okay, thank you.
So now I'm replacing Mohamed, which is the guy in the photo picture over there, presenting a IANA registry for Lisp packet type allocation and shared Lisp experience. Okay. So the problem Matt is trying to look at is that there are several extensions that have been proposed in the for Lisp, and its functionalities. Beside the control plane messages that are already been defined in the RFCs, there are a few ones defined in other documents that are not yet RFC, right? So it might be also possible, especially with the rechartering, that in the future there will be further extensions and so new types of message that may be necessary, right? So since we have only 4 bits for the type, okay, so which makes a very limited space, and we need to keep track of the types that are actually used. And so far today, you only know the types by looking at the different documents, okay? And there are no values for experimental use. Yes, Dino?
We're talking about packet types or LCAF types? Packet types are all in one place. I don't understand what he's referring to.
Maybe we'll be clear later. I mean, so
I think he's referring to his own documents, which have proposed some additional packet types.
yeah, it's on the concept plane. So the proposal basically is to create an IANA registry, okay? And in particular, he's proposing to use range 5.7 and 9.14 assigned with a standard action, and 15 as an experimental use, okay? So if we use value 15 for experimental use, we may have some conflicts if we don't manage completely the environment and maybe two or more different experiments overlap or leak in each other, okay? So that's the proposal he has in this document, is to have a Lisp experimental message type. So the type is 15, then there is an experiment ID and some experiment specific fields, everything that is afterward, basically, okay? And so in the IANA registry is proposing to also create a registry for the experiment ID based on first come, first served policy. So basically the task has a code point with no particular examination or whatever. So he's asking for comments, which I can relay to him, okay? He's asking, consider for the working group adoption. I can answer as a chair, we are still on the old charter, so today is not possible. Depending on how this document evolves, we can really talk about this in Berlin. We'll see. So any comments you wish to share with him?
So I think it seems a decent proposal. Having an experimental type can certainly help with experiments, and also proposing a format for the experimental type defined that also will give some order. So, and I don't think we need to change the protocol at all. It's just a matter of creating the registry, and we put a little order rather than having people going around with their message. I can see that people may want to play with message types for the protocol, right, because of the extension. So it seems a good thing, but
Well, defining new message types means they have the intention of changing the protocol, but.
Yeah, that's right. But not only them, right?
Yeah. Yeah.
Even the working group itself, right? If we define a new message type, we will have to pick one.
So my comment is maybe type 15 should be considered maybe JSON encoding, so it's super flexible. I mean, if you ask for feedback, so maybe that would be better. And then you can use dictionary arrays to see what's there and what's not and parse it. I don't know if there's a requirement for super high speed where it needs to be binary encoding, but that is some input. Right?
No.
Not XML, but JSON.
Maybe he likes XML, you don't know. I will tell him. Okay. So our guess is Stefan.
Hello, everybody. So this is Stefano Secci. I'm presenting another work from Orange, so by Mohamed Boukader and Christian Jacquenet. Next slide. So the idea of this proposal is to try to think how different mapping systems, so distinct, independent mapping systems, can coexist and can be interconnected to each other in a, let's say, dynamic way. So this is one of the assumptions of this proposal. Another assumption is that, so this second bullet, I had some difficulty in understanding it, but eventually the meaning of this second bullet is that another assumption is that there will be a hierarchy, an implicit hierarchy of mapping systems around, such that a Lisp site or a mapping system may have some local preference or kind of preference established over a mapping system rather than another one. A third assumption is that in this configuration, when you have independent distinct mapping systems, a mapping system may have a global view or a less global view, or could contain a portion of the mapping entries around. Next slide. Okay. So this, the idea that has been discussed in the Lisp Lab project, where these ideas come from, is that essentially we would like to avoid a forthcoming situation in which you have a high fragmentation of mapping systems, so everybody does his own mapping system, and there is no automated way to interconnect them. Okay, so that is to avoid fragmentation at the mapping system level. So the goal here is to try to think how we could help independent mapping systems to discover each other and interconnect one to each other. Next slide. So for example, here in this example, you have 5 mapping systems. So the questions that is in the air is, what are the mapping systems available? So who does this question? So this could be a Lisp site, so an Edge site, or this could be another operator, an operator of a mapping system that is interested in getting more reachability information about mapping trend entries, alternative mapping entries, or exceptional mapping entries that could be available in the internet. Okay. So supposing that there is a discovery mechanism of mapping system, that is that, okay, I know there is this and that mapping system giving me some mapping entries for that EAD prefixes. So the idea is to let these entities willing to get these additional mapping entries to have the possibility to invoke the mapping system being legitimate for a prefix, invoke it, to get the mapping entries or to get a kind of subscription, a long-term or medium-term subscription to the mapping system. So how to do that? The proposal of the draft is to define an extended BGP community such that when you announce an EAD prefix through BGP, you give the identifiers or a contact point such that who receives this community identifier is able to autonomously take the decision of contacting the mapping system. So this identifier that is to be transported in the extended community field can be an IPv4 or an IPv6 address. So this is not meant to be a mapping server. This is a generic contact point that could be used as a mapping server or not. So they made stress that this identifier could be an IP address used by a negotiation protocol. For example, if the one who wanted to contact this mapping system is another mapping system that want to establish an interconnection request, start a negotiation procedure, or this could be used by a Lisp domain that use this IP address to initiate, again, a mapping system subscription request or any other type of interconnection subscription request. So this is out of, so how to perform this subscription, this interconnection phase is out of the scope of this draft. So this, what this draft is proposing, I repeat, is to allow for a BGP extended community, an extended BGP community to transport identifiers of contact points to get in contact with a mapping system that is being announced by an autonomous system when announcing an EAD prefix. More contact points may be announced for a single prefix. Okay, that is questions, comments?
Hi, this is Dino. I see several problems here. First of all, I'll go from reverse to forward. Is it a new BGP instance or it's the underlying BGP that the community is going to be added to?
Underlying BGP, I would say, if I'm not mistaken.
Okay, so there's problems with both. If there's a new instance of BGP, that means you have to add a separate infrastructure similar to what we did with ALT to convey that information. I'm glad you said it was the underlay, but overlay information shouldn't go in the underlay, and all IBGP routers along the path are going to have to store this and not use it. So I think it's a bad idea. Now, the best way to connect mapping systems together is really no different than if you're a router and you're connected to two different service providers. How do you get packets for your prefixes? You advertise the prefixes into both. Okay. Now the problem is you can't depend on what upstream provider will get you your packets. But we don't have this problem here because the mapping system is over the top. So if you want to participate in multiple mapping systems as a Lisp site, your ETRs register to both mapping systems, or 3 or 4. I think it's going to be a really bad idea to have mapping systems connect to each other with this interconnection sort of facility, because there's going to be instance IDs and EIDs that are not going to be unique, that will have to be resolved. And we'll either have to, we're going to have all the import-export rules we have with MPLS VPNs as we do today. And it's the largest OpEx that service providers have today. So one way to connect mapping systems together is maybe the two mapping service providers want to use a route that connects both of them using DDT. And then they decide, I'm going to allocate these instance IDs for these VPNs, and I'm going to use these. Okay, so that's if they could fit into the same DDT tree, then they've just merged it into the same mapping system. Yeah. That's what I would recommend, okay? But if they need to be kept separate for policy reasons or privacy reasons, then those two mapping systems could go to that site and say, you will be my customer for both. Register your prefix in both. And by the way, if you're registering a 10/8, which is a private IPv4 address, when you register there, you use instance ID 1. Here, you use instance ID 2 because I allocated instance ID 1 to somebody else. That's the best way to solve the problem, in my opinion.
Yeah, so this has been discussed in the meetings of these French projects, so Lisp. Well, so this is not meant to be an alternative way of distributing mapping entries. So this is not meant to be an alternative to DDT or whatever. So the idea is that each mapping system has his own way of resolving mappings. And DDT may be the default choice or maybe the backup choice. Okay, so the idea is not to oppose to a legacy system. Now, yes, so if, in my opinion, ETR registers to different mapping servers belonging to different entities, then you are somehow implying that there is a kind of authority managing the DDT routes. That is, you are kind of excluding a distributed self-management of mapping systems and mapping solutions. Yeah, this is more or less, if I resume correctly the discussions. Yeah.
So if you connect them together with DDT, the two organizations would manage the routes to each other. They wouldn't need a third party, or they wouldn't have to decide who is the parent and who is the child. That's always been a problem in the internet. Everybody wants to be on top, right? So I think the way with multiple routes and multiple hierarchies, you could be peers, so to speak. I'm using that term loosely, not BGP peers, but peers in terms of I point in my routes, I know what your prefixes are for your customers. Now, it's going to be very difficult. It's easier in V6 because I hope we'll have some hierarchy in the PI space. But in V4, I'm worried about the.
But you do need that kind of authority, or you need that kind of language to let people interconnect somehow, right?
Yeah. So when ITRs in mapping service provider 1 do lookups, and it's not down their tree, then they know they have referrals to go to the other tree, and they use those children. And likewise, it goes the other way.
Yeah,
and
the configuration is done by someone, right?
So the roots are separate boxes that can point to the children of their mapping systems that already exist, and then you tell the ITRs which routes to go to. Or yeah, actually, the ITRs just go to map resolvers, and the map resolvers are in their topology. So it's their configuration of their own equipment. They really don't have to touch the sites.
Yeah, but so the point is that still you need someone manually configuring something somewhere.
But these things need trust relationships. I don't think you can just grab a set of mapping things and say, "Oh, you guys should just cooperate." I'm having real trouble getting my head around how that would work.
No, the trust relationship is just like the trust relationship you have with BGP, right? Are you worried that you're pointing to other things in the hierarchy that you might not?
Well, I mean, I understand how with DDT, with a DDT mapping system, I find my DDT mapper, my map resolver, because that's what I have to talk to as an ITR.
But you're assuming it's one trust model and one.
And then there's a
yeah.
trust model in there. And there are, in fact, security credentials between the map resolvers and the DDT entities.
Oh, the same if it went cross service providers, because there's.
Yeah, but that means you have to make sure you only discover guys with whom you share security credentials.
No, you refer things to me, and you can choose the public keys that you want to. So
yeah,
it's
but
pretty secure.
When I refer a request to you, and you're picking somebody from this BGP advertisement.
BGP advertisement?
That's what this thing is saying. I went and looked at the draft.
Oh, yeah. Well, I think it's.
We have a few minutes, and Robert,
Yeah,
there will
Robert
stand in
Rashford,
front.
a couple of comments. So you have suggested extended community. First, extended community lets you play with 6 bytes. Is it enough for your entire discovery, who to contact? I'm not so sure. Second, the extended community gets filtered heavily across any boundaries. So that's not to be a good example. However, you are solving the problem which has been solved. I mean, think about this from the perspective of the current internet and internet exchange points with route servers. If you really have a zoo of mapping, independent mapping domains, you can augment current IXs with a Lisp mapping RS and exchange information that way.
RS, you mean root server?
Route server, yeah.
Yeah, I wanted, Padma, I just want to add something. I think it's really a bad idea because if you try to map into the BGP extended communities, those are going to be per prefix, and those communities are usually aggregated. And here you would expect not to have aggregated. So how are you going to solve that too?
Okay. I will report about this question. I can't give a clear answer about that. Yeah.
Okay, thank you very much, Stefano. So this leads to the end of for today. I mean, we have 1 minute if there is any comment, unless we see each other in Berlin. Thank you very much.
If my map resolve understands the aggregate scope, there is no conflict. In fact, from my point of view, they saw my map. I send a request to map resolve, and he knows to ask X about this and Y about that, and the right things happen.
That was one of my alternatives.
Still, you
You
know,
registered both.
Well,
And then
I
it doesn't
haven't
matter.
registered. I made it to talking to someone.
So send a map request to your results.
My results are to belong to both. But I'm registered in only the one that has the appropriate scope.
The only way the result is belong to both is it uses TDT and the other one. And that's kind of what I said.
Yeah, that's what you were saying.
Yeah. No, but no, I'm asking you what you think.
So I think that works. I think if the resolver participates as a resolver in both systems.
Yes.
But the registration process is only in the system that has
I came along
scope
here
for
when I
my
was your judge.
EID that I am
You're
registered.
actually saying something different. You're not saying connected to the TDT. You're just saying you register to one map server.